In the previous video, we talked about the effect of shear span on concrete shear strength, and that as the shear span to depth ratio, so if that's D, as A to D decreased, as A got smaller, the strength of the concrete in shear increased. Let's continue our discussion of shear strength of concrete. It's by nature phenomenological, that is, it's determined from experiments. And this equation was in the code up until 2019, last year. And you can see that this right here represents D over A, the upside down of the shear span ratio, 1 over the shear span ratio. And no matter what this equation comes out to be, you cannot be greater than 3.5 square root F prime C for VC, and this represents pure diagonal tension failure. And this is what was in the code until last year. And some of the concerns about this equation were that it seemed to overestimate VC for low shear web reinforcement ratio. And so just this past year, there's another equation for V sub C, and so in 1977, there was this equation here that no longer had the shear span ratio in it, and it had a lower upper limit, and it just was a function of the amount of long steel. Rho W is just AS over BD, and if you have a T-beam, it's the B of the web. But this was not adopted. And so in 2019, just last year, this was adopted. Okay? NU is axial load. And you can imagine if you compress a beam in compression, if you load a beam in compression, it's harder to shear. But for us, that's 0. So all we're really looking at for our class is this and this. Okay. And because NU is going to be 0. And this is the shear strength equation if you have at least minimum stirrups. Okay? And if you don't have stirrups, this equation changes slightly, and we'll talk about that later. But notice that this also is a function of the amount of steel, long steel in it, but it's now to a 1/3 power. And again, there's no shear span ratio in the VC. Now, if you look at the shear strength equation for pre-stressed concrete in the 2019 code, it still contains the term that has the shear span ratio in it. So it's not completely gone away. And you get your choice of which of these two you're going to use. And in our class, we're going to use this simplified one. But this is not as bad as it looks, this one right here. So I want to talk about this a little more. It's a function of how much steel is in your beam. And so I want to look at the comparison of these two. And what it boils down to is you have this right here, 8 rho to the 1/3 versus 2. Everything else is the same, the lambda and the square root F prime C. So what we want to do is compare 8 times rho W to the 3rd power versus 2. And remember, rho W is just AS over BD. And we've talked about this in class, and a good percentage of steel in a beam is about 1%. But let's look at the complete range of rho. And so what I've done here is calculated rho for different combinations of F prime C and Fy. And remember, you could do that. And so rho min and rho max are just functions of those. So here is the lowest rho min, 0.5%, and the highest rho max for using phi of 0.9. So I'm not going to use the rho that goes all the way down to rho balance. I'm going to use the one that gives a strain of 0.005 at the bottom. And that highest rho is 2.58%. So rho practically, and this is, you would not go outside of this likely, 2.58%. And typically we're shooting here at about 1%. This one, right, where did it go? Right here. This is the one we often use. Okay, so what I did was I plotted 8 rho to the 1/3 power as a function of rho from 0 all the way up to 3%. And remember, we're comparing this to 2. So we're going to compare that to 2. And so here's 2. And this is where they intersect. And this percentage here was 1.56%. And so anything below 1.56%, you're going to use the 2. It makes more sense to use a 2. And anything greater than 1.56%, you would use the complicated equation, which was 8 rho to the 1/3 power. It's not that complicated. Okay, we typically have 1% in our class, so we are usually going to use VC equals 2 square root F prime C, and remember, F prime C is always in PSI, BD. I think I'll stop here and I'll make another video to talk about more ACI requirements.